A 3ds Max photometric light can assume many different forms to emulate the shapes of various lighting fixtures. We can emit light from a point, but more accurately, we can emit light from an area or a volume using various shape primitives. Let's render this in active shade with the default point light we've got in the scene. And let's move that down. We'll grab that and choose the Move tool, position it closer to the ground plane. That'll make it easier for us to see the effects of the various shapes. Let's set the Z position to a value of 0.2, and then go back to the Select Object tool. With that light selected, let's go over to the Modify panel, and it's got the default shape of point, which is an infinitely small point. It has no area. And the default light distribution type over here is uniform spherical. It's a point that's emitting light in all directions equally. Let's bring the intensity down a little bit so we can see the effect of changing the shape. We'll set the intensity to 1000 candelas. So there's a point light source. In the shape/area shadows rollout, let's change the shape over to a different primitive. Let's choose line. And now we see we've got a linear shape, but it's still got no area. It's just a one-dimensional line. We can change the parameters. We've got a length parameter here. As we increase that, we're going to spread the amount of illumination over a larger area. The total number of lumens or candelas emitted is constant. Let's set the length to 1.15 meters. And that's the length of a fluorescent tube in my scene. If I really wanted a fluorescent tube, then I should probably use a cylinder primitive instead of a line. I'll get in a little bit closer in the viewport with Control-Alt-Middle mouse button and change the shape over to cylinder. And now we can actually see a reflection of that cylinder in the shiny polished concrete floor. But we can't see the cylinder itself unless we enable rendering light shape visible in rendering. Turn that on. And now we can see we've got a cylinder. It doesn't have any caps, but we do have a cylinder. For a fluorescent tube, I'd want a lower radius to the cylinder, so I'll bring that down to 0.02 meters or 2 centimeters. Now we've got a nice fluorescent tube there. I could populate my scene with lots of these fluorescent tubes, or I could make things simpler on myself and just use a rectangle shape and place it over the light fixtures. And that will give me a little bit faster render time because Arnold or whatever renderer will not have to calculate as many lights. So we can change our shape over to rectangle. And as soon as we do that, we see something really strange. We're getting a cylinder instead of a rectangle. Looks like a rectangle in the viewport. We're getting a cylinder in our production renderer. What's happening is Arnold is interpreting this width value as the radius for a cylinder. That in turn is happening because our light distribution type is set to the default of uniform spherical. Well, for an area light, generally we want it to be one-sided. And so we don't even want a spherical distribution type. Change that over to uniform diffuse. And now we've got a one-sided distribution type. We're only getting light emitting from one side of that rectangle. It may take a moment for our viewport to catch up with Arnold, but eventually we'll see that we're only getting light on one side of the rectangle. And if I orbit with Alt and middle mouse button and look underneath that light, we can see that in our active shade rendering with Arnold, we are getting that light shape visible in the rendering. We just can't see the back side of it. We see straight through it. Okay, to cover one of my panels, I'll set the width over here to 0.54 meters. And I'll dolly back out again, Control-Alt-Middle mouse. And so that I can see where I'm positioning things, I'll turn on edged faces in the viewport with F4. Grab the Move tool once again, and I want to position that light inside one of these fixtures up here in the ceiling. I already know what values I need, so I'm going to just plug those in. I'll set the X position value to negative 2.575. Press Tab. Set the Y position to 1.05. Press Tab. Set the Z position to 3.985 and press Enter. And now that light is positioned just where I wanted it to be inside that fixture. Of course, we'll need to increase the number of candelas or lumens to brighten this up. So we can set our candelas up here to, let's say, 20,000. Okay, not too bad. This looks more or less properly exposed for one light, but the office actually has many ceiling fixtures. After duplicating a bunch of instances of this light, the intensity could actually be something more like 10,000. So I'll bring that down. Candela's value of 10,000. And that equates to about 30,000 lumens or so. An actual fixture of this type would probably put out about 3,000 lumens. But if we entered 3,000 here, we would get a drastically underexposed shot. Just to illustrate, if I bring that down to a physically accurate value of 3,000, now it's underexposed. We could adjust the rendering with exposure control, but I don't recommend it because we cannot disable the tone mapping of the contrast curve. We'll talk more about this later. If you're rendering lighting studies for architecture and interior design, or just trying to reproduce the conditions of a real-world interior, you'll want to multiply the real-world lumens values by some amount in order to bring the light into a good range for rendering. A good starting point is to multiply all the real-world lumens values by a factor of 10. So for a 3,000 lumen light fixture, I would set the lumens to 30,000. And now we've got a pretty good rendering in our view, and we can avoid mangling our output with exposure control. As long as we multiply all of our light intensities by the same amount, we will still get photometrically accurate results. And by the way, if you wanted a more artistic or realistic look to the actual light fixture itself, then you would probably want to disable light shape in rendering and render some self-illuminated geometry there instead. That is a lot more setup, but it gives you more control. Okay, for the purposes of this demo, I'll turn light shape visible in rendering back on again. That's how to set up a photometric light's shape and distribution type.